Hi, Chem Peeps. I wanted to talk about exceptions that we might see when doing electron configurations. Over here on the left, you can see that two exceptions you might see are with elements that are found in the D4, which would be chromium's column, and in the D9 column, which would be copper's column. These elements, because of stability and lower repulsion energy, you will see that at the end here, there's a different configuration than we would expected. Normally, you might write this as 4s2, 3d4. And beginners would often do it this way, but as you learn more about the stability and the repulsion energy found within the atom between the electrons, we find that it is more stable for elements found in the D4 and the D9 column to shift one of the electrons in the S cloud over to the D cloud. And so every atom or element found in chromium's column is going to end in S1d5. And likewise, all the elements found in copper's column is going to end in S1d10. And you can just explain this as there is less repulsion energy for the electrons to move into this configuration. Likewise, when we're talking about the elements that are found in the 4F row and the 5F row, we find that there's a shift going on there too. You can see here that these two configurations here, I have a 5D1 before I go down to the 4F, and a 6D1 before I go down to the 5F. In fact, on this table, you can see that they've actually moved these two elements down in front of the 4F and the 5F. If I count across the 4F and the 5F rows here, I don't have 14 blocks. I have 15 blocks because the elements that came before the 4F and the 5F have been moved down there. It is more stable for the atom to fill that 5D1 and that 6D1. So when you look at electron configurations written for elements from the 5F and the 4F, this is from the 5F row and this is from the 4F row, you can see right here, before they go down to the F row, they have filled the 5D and the 6D. Just one. Now here, osmium, it is in the D cloud. It is in the transition metals. It's found right there. You can see that it has normalized. Now, I got this off the internet, and you can see that they did not write this one or this one in the correct sequence. And that's how sometimes I know my students are copying rather than writing it from their own understanding. If we were doing this in class, we would say 6s2, 5D1, because it's going to fill that first, and then it goes down to 4F1. And then here for this one, down here, the osmium one, it's going to be Xeon 6s2, 4F14. And why did I write this one first? I want to explain here in a minute. And then 5D6, where it lands in the transition section. I have filled this up completely. This one, I'm just filling that one block in the D cloud before going down to the 4F. Likewise here, I'm just filling that one block in the D cloud before going down to the 5F. And so those are the exceptions that you might see on the periodic table. This is just an additional video in the series of electron configurations that I've done. I thought it might help some of you more advanced students that are doing some of the harder configurations. You can find me on TikTok and ChemChats at TikTok and YouTube at Chem's ChemChats. I will talk to you later.